So the very first thing we want to do now that we have a brand new Houdini scene, so we want to create a geometry node on object level so that we can import and create all the things we need. So we're going to jump in here into Geo1. And in order to get our alembic that we created in Cinema 4D over here to Houdini, we need the alembic SOP. So what the alembic SOP does is fairly self-explanatory, right? It imports our alembic file, but Houdini has some really nice tools for handling alembics. So let's go ahead and I'm just going to import in my cubes. Now, you'll notice that they come in pretty big. Like this is a huge, huge cube. And usually what you need to do is either change the scale in Cinema 4D or just transform it here in Houdini. Usually it comes in about 100 times too big. So let's drop down a transform SOP and let's scale this down 0.01. There we go. Cool. So there's our cube. So let's look at what we have here. We have 2 points. That's weird. I'm sure we had many, many more points in Cinema 4D. The reason we're only seeing 2 points is because what we have is packed alembics. And packed geometry in Houdini is a really, really handy tool for Houdini to save memory. It's kind of like instancing, right? Like in Cinema 4D, when you have an instance of an object, it's basically just a copy of another object, and you can't really do anything with it. It just gets put on a point in space, right? Like if you're doing render time instancing, for example, in Redshift or something, or you're using geometry instances in X particles or in thinking particles. Same kind of thing. That doesn't really do us any good. We need to take this out of this kind of packed state and get it to something where we can actually work with it. So in order to do that, what we need is an unpack node. So we're going to take this and we're just going to drop it right in line here. That looks a little bit more interesting. So let's see what we have now. So we have all these points. We have our primitives. We have these 2 polysoups. We don't want polysoups. Polysoups in Houdini are kind of another memory saving tool. So we're going to convert those to actual polygons using a convert SOP. We're just going to throw this right in here. Convert SOP is really handy because it'll convert all kinds of things to all kinds of other things. So you can convert from all of these different types of things to all of these other types of things. In this case, we're going to leave it default, which is from all types to polygons. So we're going to convert from polysoups to now proper polygons. Great. Now we have actual geometry. I can tell, though, that we have a lot of intersection going on, and that's because we have 2 cubes, right? We made 2 cubes. One was a really dense cube, and one was a little less dense cube, and they both have different levels of noise and stuff going on. But right now, they're kind of intersecting each other. I don't really want that. That's not really going to work for me. So what I'm going to do is come back up to my alembic node. I'm going to go over to the selection tab on my alembic node. I'm going to go to object path and grab this little ladder thing. And what this is, it's basically, you're going to see here, this is basically our object manager in Cinema 4D, right? I have my 2 cubes. I'm just going to select my first cube, and that's it. So now my other cube is not there anymore. And I think what we're going to do, let's do this. Let's grab this because we're going to want it at some point. Let's just bring it in here. I'm just going to alt drag all of these nodes over here so we create a second copy. Go to this alembic, and in this one, I'm going to select cube 1. So now I have cube 1 and regular cube. So most of our actions are going to happen here on the regular cube. We're going to use cube 1 a little down the line. So let's go ahead and label these things. I'm going to throw in a null object. I'm going to call this in base cube, and I'm going to duplicate that, and then I'm going to call this one in dense cube. Just like that. Cool. So now they have labels. Now, one of the things I could do that I kind of like to doing is changing the color of nodes just to make them pop out in the interface a little bit more. And it's purely just an organizational tool. It doesn't have any effect on anything. It's just there for organizational purposes. So I can, with my mouse over here, I can hit the C key and it brings up this little color palette. And so I'm going to change these two nodes to be, no, let's do this kind of reddish maroon color. Okay, so that means that like when I'm way back here and I'm looking at all of my nodes, I can tell where my endpoints are. That's pretty cool. The other thing that we could do, just for purely for organizational purposes, is select all these and drop a net box around them, which is this guy. Select this. So now we've got this, and we can actually label this. This is in dense cube. And I could even change the color of this if I wanted. If I hit C, I can change this color, change it to whatever I want. Sure. Yeah, we'll just leave it like that. That's fine. So that way I know this is all of my dense cube geometry. Great. So let's do some processing. Now that we have this stuff in, let's look at what we have that we're actually going to be able to work with. So I'm going to middle mouse this. So we've got our position attribute for P, which we would expect. And then we have a whole bunch of vertex attributes. And this is how Houdini sees the vertex tags in Cinema 4D. When you export an Alembic, all that vertex tag data, that gets stored as attributes, conveniently enough, on the vertices. Before I continue, I want to look at this vertex attribute that I've got coming in, or I should say all of these vertex attributes I have coming in. So we're going to middle click this, and we can see that all of our noises are actually coming in as 3 float color values. They're basically coming in as vectors, but look at the values over here in the geometry spreadsheet. R, G, and B for these are exactly the same number. So I knew that I was creating something gray in Cinema 4D, but now that they're over here in Houdini, they're coming in as RGB values, which is actually like tripling the size that they really need to be. They don't really need to be all that big. So what I'm going to do is I'm going to change that. I'm going to basically create a float attribute and take one of those parameters, either RG or B, and make that the float attribute. Since they're all the same, it doesn't really matter which one I pick. And I'm going to show you a couple of different ways to do it. The first way I'm going to do it is with a VOP. So we're going to do it the VOPs way first, because we've looked at VOPs already. So we're going to run this VOP instead of over points. We're going to make sure to run this over vertices, because these are vertex attributes we're dealing with. So in VOPs, let's make a little space. What I'm going to do is I want to make sure to bind in my attributes. So I'm going to bind the attribute. The first one I think is noise booyah. Yep, there we go. So we're going to do, this is a vector attribute. We're going to do a vector, and this is called noise underscore booyah, like that. Okay, so that's going to bring that in. Now, what I want to do is I just want to pull one of those values off of that vector and make that a new float attribute. So what I need is a node called vector to float. And what that's going to do is it's going to take my vector and it's going to split it out into its 3 components. And now I have access to all 3 of these. So I'm going to bind export a new attribute. This one's going to be a float type. And we're going to call this, we're just going to call this noise1 for the moment. I may go back and change that. So it doesn't really matter which one of these I pick, because they're all the same, X, Y, and Z, or RGB are the same values in this case. I'm just going to grab the top one and we're going to bring that in. So you can see now what it's done is it's created this noise1 attribute, and it's the same value as all these other ones. Awesome. I'm going to do the same thing for the other two. So I'm just going to duplicate these nodes here. This one is going to be the next noise, which is, I believe it's noise turbulence. Yep. See if I can spell it correctly. There we go. And this one, we're going to output noise 2. Let's just make sure that wrote. Yep, there we go. We've got noise 2. That's great. And then this last one, noise VL noise. Yeah. VL noise. And that one's going to be noise 3. Awesome. Cool. So I've got all those values in place. That's great. So that's the VOPS way of doing it. The other way I want to show you is how to do it in a wrangle. Now the wrangle nodes, if I type in wrangle, we have quite a few of them here. The wrangle nodes are where you input vex code. So if I drop down a vertex wrangle, and to be clear, the vertex wrangle is basically just the attribute wrangle. If I make a attribute wrangle, it's literally the same thing, just automatically set to vertex. So if you look at all the wrangle nodes, there's no difference between the point wrangle and the attribute wrangle. The attribute wrangle is the same exact thing, just set to point mode or primitive or vertex. The differences though, the deformation wrangle, the height field wrangle, and the volume wrangle are actually different. So if I look at this attribute wrangle, I can only make these types of wrangles here, where if I dropped in the volume wrangle, that's actually going to be a completely different node. So if you're just running over SOPs, SOP geometry, standard SOP geometry, you could just use an attribute wrangle and set it here, or you can use the named wrangle. It doesn't really matter. Houdini has some of these redundancies kind of built into it. So I'm going to keep my vertex wrangle. We're just going to keep this in here. So we're going to do the exact same thing. We're just going to do it in the code. So what we need is we need a attribute, that noise1 attribute, to store the one of the properties of our first noise. In this case, it's going to be noise booyah. So what we need to do is create a float attribute. And since we are creating an attribute out of thin air, Houdini needs to know that it's a float attribute so that it knows how to handle the data coming into it. So in order to do that, what we do is type a lowercase f for float, and then we do the @ symbol to let Houdini know that this is a float attribute. And then we're going to type in noise1. So that's going to be our attribute. Now we're going to set that equal to noise booyah. We're probably going to choose X. Let's just do that. Noise booyah X or noise booyah R. It's sort of the same thing. But again, because noise booyah is a custom attribute, Houdini needs to know that that is a vector attribute. And in order to do that, you type in v at noise underscore booyah. And then we want the X property of that. So we're just going to do .x. Cool. So this is going to set the float attribute noise1 equal to the vertex attribute noise booyah X, right? The last thing that Houdini needs in order to make this work, all command lines in Vex have to end with a semicolon, just the way it is. Otherwise, it'll throw an error. If I get rid of the semicolon, now it's angry, right? I get this dumb error message. But if I throw the semicolon back in there, oops, all good. Happy Houdini. Okay, so we're going to do the same exact thing for the other ones. I'm just going to copy, whoops, do that. I'm just going to copy that, and we're going to paste it a couple of times. And we're going to say noise 2 and noise 3. Let's go remember what these are called. So this one is going to be noise turbulence. .x, and this last one is noise underscore VL noise. VL noise .x. Great. So we literally have the same exact thing, just two different ways. So there's no difference whatsoever between these two ways of tackling it. You can do it the VOPS way, which is to bind in our noise attribute, pull off one of the components of our vector, and output a new float attribute. Or you can do the same exact thing in a wrangle by building 3 brand new float attributes. Doesn't matter either way. I'm actually going to keep the wrangle version, but we'll stash this attribute VOP off to the side. The next thing I want to do, because now I actually have even more data in here than I did before, I sort of went backwards. What I need to do is actually remove the old attributes. So we're going to do an attribute delete right below that. So what we're going to do is in the vertex attribute, we're just going to delete noise booyah, noise VL noise, and noise turbulence. Great. So you can see now that we have done that, our memory usage is down to 317.02 kilobytes, where before it was actually 534.16 kilobytes. So you can see there's actually like a marked difference in memory usage. And we're dealing with not that many vertices here, right? Like we only have 5,400 vertices. It's not like we have a ton of information in here. If we had 54 million vertices, now all of a sudden we're talking about a significant memory savings, which is absolutely awesome. Okay, so the next thing we need to do is take these attributes off of the vertices and move them onto the primitives. And we can totally do that using a node called attribute promote.